Okay, let's continue now. So we're going to have a look at the remainder theorem. So before we actually go into the remainder theorem, just a little bit of vocabulary. So just to be clear, x squared, or let's just say 3x plus 2 equals 0. We call this, these are called the factors. And these are called minus 1 and minus 2 are called the roots. Okay? It's actually quite easy to switch between the two. So like for example, if I said 3x plus 1 is a factor, how do we get the root? It's minus 1 over 3. So what are you doing in your head? In your head you're doing 3x plus 1 equals 0, so x equals minus 1 over 3. Yeah? But suppose I said something like x equals minus a quarter. That's a root. What's the factor? Yeah, well, what are you doing in your head? You're just rearranging this. So you get 4x equals minus 1. And then you get 4x plus 1 equals 0. So this is the factor then. So, you know, sometimes you just need to rearrange between the two. You need to be careful in the exam. You know, if the question said factors and you give roots, then that's wrong. And if the question says roots and you give factors, that's wrong. Okay, so you need to be careful about that. So that's just a little bit of vocabulary. No big deal on that. But now the more interesting thing is the remainder theorem, which we'll have a look at now. Can I scroll down? Yeah. There's not really anything too meaningful here. Yeah? Here's the idea for this lesson, okay? We have a cubic. Let's say our cubic is something like ax cubed plus bx squared plus cx plus d. And I take my cubic and I divide it by x minus, let's say, k. And my question is, what's the remainder? So the problem is that takes, as somebody mentioned, long division is quite long. It'll take a little bit of time to figure out what the remainder is when you divide. And what we would like to know, is there some quick way to get the remainder? Is there some way I can quickly get the remainder without having to do long division? That would be quite useful. So the idea is, maybe there's a formula. Maybe there's a formula to get the remainder, so I don't need to bother with the long division. You know, remember with the quadratic, there's a formula to get the roots, so you don't have to bother with the factorizing. Maybe we can do something similar with the cubic. Maybe we can get a formula. So what I'll do is, I won't use any numbers. I'll just keep them as letters, A, B, C, and D. And I'll see what formula I can get if I do the long division. So the idea is, I'll pretend I have numbers, I'll do the long division, and I'll see what formula I'll get for A, B, C, D at the end, and K. You get the idea? So I'm going to do the long division, I'm going to see what the remainder is at the end, and whatever the remainder is at the end, that's a formula for the remainder, because I haven't actually used any numbers here. Yeah, we get the concept here. So this, now you'll have to keep up, because this is a little bit tricky because there's no numbers. So let's scroll down a little bit. Okay, so let's start the long division now. So we'll do this nice and slow. What's the first one here? It's got to be a x squared. So that's fine. So we have ax cubed minus a k x squared. Now do you know what? We'll just not go too fast here. So the next step is minus. Now that's okay, because these two cancel and these two combine, and they combine to make b plus ak x squared, because I put these together. You know, just pretend they were numbers. You know, if this is 4x squared minus 2x squared, you would have 6x squared, right? Because you combine these coefficients, so that's what we're doing here. So now we see why it's getting a bit trickier, because what's the next one? What's next? B plus AK x. Alright, so then this is B plus AK x squared. Oh, sorry, I forgot to carry down my CX and D. Okay, so B plus AK times x, there we go. And then B plus AK x times K. That would be minus BK. B times K is BK, and AK times K, AK squared x. And now I combine, and just to be clear, it's minusing the C minus minus plus. So it's the C plus this guy. So what's that left with? C plus BK plus AK squared x, carry the D. Good news. There's only one left. What's the last one? The whole thing. C plus BK plus AK squared. Squish that over and just let the thing disappear. Can I zoom out a little bit? Can you still see that? Yeah. Okay. So C plus BK plus AK squared x minus CK plus BK squared plus AK cubed plus D. So what I have at the end here is the remainder. So the remainder equals D plus CK plus BK squared plus AK cubed. Now that formula is quite a big formula for the remainder, but you might recognize it as being a familiar thing. And to make it even more familiar, let me just write it backwards. Remainder equals AK cubed plus BK squared plus CK plus D. Yeah, it's just the x replaced by K, yeah? Yeah, well, good thing there's a YouTube recording for you to watch it again. It's quite a long process. I can answer particular questions, but I can't answer ambiguous questions. So if there's a particular step that's unclear, or if it's not clear which term I got, but really it's a normal long division, except you have letters instead of numbers, and that makes it much more painful to do because you haven't got numbers to add together. Like for example here, this wouldn't be number plus number, it'd just be one number, because you know, if you had 3x squared and 2x squared and I minus them, what do I get? I get x squared. But if they're letters, I can't do this, so I have to keep all my letters separate, which makes it quite big. But at the end I get this as the remainder. Yes? Oh yeah, the time for this one then. So 9:34 is for this one. Yeah.
Why don't we use this instead of...
Oh no, don't. I don't like this long division. No, it's only easier because that's what you're familiar with. That's why it seems easier. Anyways, somebody spotted that this is the original cubic, except x is replaced by k. So actually I could come up with this. Or equals the cubic with k. And this is the formula. Now that's a really, really, really big deal. Because what you're saying is, what's the formula for figuring out the remainder? The formula is the cubic itself. So what exactly does that mean? Well, let's have a look at an example. So I'll give you a minute to write this down, obviously.
Sir, is this formula applied to all the functions?
Yeah, it's not just cubics. It would work for any power. Yep. Oh, something like quartic, I think, yeah. And 5 is quintic. But then after that we just say degree 4, degree 5, something like this. Yeah. Question?
Yeah. Number one would be, what if the remainder is 0? This would be
Yep. Will still work.
Yeah. And the second question would be, what if the x of the denominator has a power?
No. This only works when you're dividing by a linear.
So can we use this in the previous one?
Yeah, which is what we're going to have a look at now. So can I scroll down? So let me give you an example, okay? Let's say I have x minus 1 divided into x cubed plus x squared plus x plus 1. I know the remainder is 4. Don't believe me? Let's check it. So, what's first? X squared, so that's x cubed plus, minus x squared, 2x squared plus x plus 1. What's next? 2x. 2x squared minus 2x. What's next? 3x plus 1. 3. 3x minus 3, remainder is 4, like I told you. Well, that's stupid, because that'll take a while. So instead, let's use our new formula. X cubed plus x squared plus x plus 1 divided by x minus 1. Remainder theorem says you can just use that with x equal to 1. So if I put 1 in here, what do I get?
4.
Yeah. So you see, the remainder theorem is a very, very useful theorem. It says you can get the remainder by just taking this as a number and putting it into the equation itself. You put in minus 1. Now, what would you do if it was something like this? So if you wanted to divide it by 2x minus 1, what would you use for x? 1 over 2. Yeah. Question, yeah? Oh, yeah. So if you had like 2x minus 1, you would use 1 over 2. Yeah, so you see how useful the remainder theorem is? You would use 0. Because if you think about it, 2x is like 2x plus 0. So you would use 0 over 2, which is still 0 then. Yeah.
Does the numerator have to apply to like this format x3 plus x2?
No, in fact the numerator could be quadratic, it could be cubic, it could be anything like this. Yeah. The only thing right now that we want is that we divide by a linear. Yeah. Shall we do another example of using the remainder theorem? Can I scroll down? Yeah. Three x cubed plus 15x squared plus 20x plus p. When you divide that by x plus 3, the remainder should be minus 1. Figure out what the p is. Okay, so we need to figure out what the remainder is. Well, we can just use the remainder theorem. So what value of x do I use? Minus 3. So 3 minus 3 cubed plus 15 times minus 3 squared plus 20 times minus 3 plus p. That should equal the remainder. But what should the remainder equal? Minus 1. So can I figure out the p? Easily. 3, 9, 27, 5, 2, 108, is it? No. What's this here? 3 by 3 is 9, by 3 is 27, by 3 is 60, 81. Yes, 81, sorry, 81. 9 by 15 is 135. minus 60 plus p equals minus 1.
P is 5.
Thank you. P is
5.
5. Okay. This is, do I have my numbers right? Minus 1 plus 60 minus 135 minus 81 is 5? Well, I suppose I can just check. Ah, thank you. Sorry, I just copped that. Minus 81 because it's a cube, sorry. Right, so minus 81 minus 60 plus 135. Where are these three together, please?
Minus 6.
Minus 6?
P is 5.
Okay, so yeah, what's P? This is 5, yeah. Yeah, this was given to you guys. This information is given to you. You know that this divided by this gives you a remainder of minus 1. This is like a section A question in the exam. We'll do a section B question now, which will have two unknowns, a P and a Q. Section A are short questions and section B are long questions. Did you write this down? Question? Question? It's wonderful, isn't it? It's absolutely wonderful. It's wonderful. Continue? Guys, down the back, what's the question, or is it sorted? Huh? Sorted? Okay. I didn't know if a fight was going to break out. It's okay now? Yeah, alright, fine. Okay, let's have a look at another example now. Listen. X minus 5 and 5x plus 1 are factors of px cubed minus 19x squared minus 29x plus q. Okay. So if they're factors, what's the remainder? 0. And how do we get the remainder quickly? We just have to put the right value into this to get the remainder. So, yeah, what should I use for my x's? 5 and x equals minus 1 over 5. What should I get when I use those values of x?
0.
I should get 0. So I get p times 5 cubed minus 19 times 5 squared minus 29 times 5 plus q should equal the remainder, which should be 0. Likewise, when I put in minus a fifth, I should get 0. Right, let's clean these two up. 5 cubed is 125. 5 squared is 25. 25 times 19 is something, alright. What's 25 times 19? Thank you.
Minus 475.
475?
Yeah.
For sure? Okay. Is that what you got? Let's have a look, see, please. Yeah, 475. And then 29 by 5. So that's minus 145. Yeah. Plus q equals 0. Minus 1 over 125p plus, no, minus 19 over 25 plus 29 over 5 plus q equals 0. Now, what type of problems does this look like? Yeah, what method would be the best method to solve this for p and q? No, not substitution. Elimination. Because the q is all ready to go. ready to be eliminated. Okay, so let's minus them. 125 plus 1 over 125. So this ends up being 15626 over 125p. Minus 11856 over 25. Minus 104 over 5. Q's cancel equals 0. So 15626 over 125p equals. I'll add these two together and take them to the right. Look, don't be scared of big numbers. You have a calculator. What difference does it make? What did I say that was? 104 or 109? Oh, this is terrible if I can't make out my own handwriting. Did I say 104? I said it was 104, then I should believe myself. Plus 104 over 5. So, yeah. 12376 over 25. Are you sure I said 104 and not 109?
You said so.
What? I'm also hungry, so let's see. Minus 145 minus 29 over 5. Yeah, do you know what's funny? It's neither 104 nor 109, which is yes, yeah. So I was off by a few hundred there. Minus 754 over 5. That's a 4. Okay. So anyways, again, I'll add these two and take them to the right. 11856 over 25 plus 754 over 5. Much better. 15626 over 125p equals 15626 over 25. So what can I cancel on the left and the right? I can cancel the 15626, can't I? I think you mean 5 over 1. Yeah. 5 over 1, otherwise known as 5. So P is 5. How can I get the Q? Yeah, which equation's easiest for Q? No, not any of them. This guy, yeah? Why? Yeah, and fractions make us sad. Right, so 125 times 5 minus 475 minus 145 plus Q equals 0. So Q equals 125 times 5 minus 475 minus 145. So Q equals minus 5. So I got my P and my Q. That's a section B question, obviously, because it takes much longer to do. So I'll write this one down as a long example.
What's the time?
Time for that one. There you go. 24:18. Yeah. Not rounded. Oh, but this is the exact answer.
Sir,
Yeah.
if the examiner didn't request any method to use in the questions, can we use the long division?
Yeah. But here long division is more difficult because the P is at the beginning. Write this down. Guys, write this down. Did you write this down? It's very important now. I have shares in paper companies. It's important that you use as much paper as possible. Okay. Well, I think there's one more example I want to do. Because maybe maybe it was you or somebody was asking me if you're dividing by a quadratic. No, somebody was asking me over there. Did you write this down? Yes? A few more seconds and then... Well, do you know what? A couple of people are writing it down. I can squeeze in what we're going to do in a second. So, I'm going to tell you, again, it's find P and Q. Px cubed plus qx squared minus 45x plus 18. I want you to find P and Q if this is a factor. Okay, we get a start on that. Px cubed plus qx squared minus 45x plus 18. Find P and Q if that is a factor.
If?
Well, sorry, given that, if you prefer. And if is fine for grammar here as well. You tell me. Alright, let's get a start on this one. So what should I do first? Because the remainder theorem doesn't let me divide by quadratics. It only lets me divide by linears. So some of you copped that perhaps the thing to do first would be to factorize this quadratic. So what would that be? A 5? 3x minus 1?
5x plus 6.
Yeah? Minus 6. 18 minus 5. No, looks good. So when you use x equal to 1 over 3, the remainder should be 0. And when you use x equals minus 6 over 5, the remainder should be 0. And it's exactly the same now as the last one. Exactly the same. But what I wanted to do with this one is I wanted you to focus your mind on what you did here. Tell me, you really need to think about this. If this is a factor, how do we know for certain that its factors are also factors?
Because if you multiply it, you'll get that.
Yeah, but think about it. Like if I said I'm able to divide a number by 30. Listen. If I said I can divide a number by 30, is it also true to say I can divide the same number by a 6 and by a 5? Well, no, you're answering it too quickly. Like, you need to think about it. Like, it's not obvious. If I divide by 30, could I think of a number which I could divide by 30, but I couldn't divide by 6 or 5, which are factors of this? And the answer is no. If I can divide by 30, I can also divide by 6 and 5, or by 3 and 10. In other words, if I can divide by this, it's possible to divide by its factors as well.
Because in the end, 6 and 5 are factors and that matters.
Yeah, but like, okay. I'll give you one little homework question to add to this one. It's optional, but since it's so obvious, I'd like people to prove it then. So prove that if I divide by a quadratic or a number, if you don't have to use a quadratic, you can use a number. Prove that dividing by a number, if that's possible, then it's also possible to divide by its factors.
What's the question?
Yeah, I just said the question. Okay, I'll write it down. Yeah, I'll write it down. We'll say that. We'll say A divides into B. So that is, i.e., you can say B divided by A and the remainder is 0. Yeah? And you can say C and D are factors of A. So C and D, they both divide into A. So I want you to prove C and D are also factors of B. Okay, so A divides into B, that's fine, and A has factors of C and D. So I want you to prove that if C and D are factors of A, then they also have to be factors of B. That's the kind of the idea we have to use in this last example.
Is this A times C equal to B, or A times D is equal to...
Yeah, but C and D are factors of A, but they might not be all the factors. So you couldn't say A equals CD, because there could be other numbers.
Okay.
You know? Yeah? In fact, if you want, I could make it even easier for you. I don't even need the D. If you want to just do it for just one of them. So C is a factor, then prove that C is also a factor of B. I'll make it even easier for you, because I'm such a nice guy. Right, C is a factor of A. This is optional. Prove C is also. Okay, so you can get started on your homework. And if you're looking for something interesting to do, you can even start with this proof. So again, first and last.
What was the question you called the voice?
Huh?
The one.
Oh, yeah. I didn't. It was this one here. Anyways, you have it in the video.
I mean, we didn't solve it, did we?
No, because I got it to a point that made it the same as the previous example. Yeah. Anyways, I've given you to finish it as a homework, because that is actually question 6A. Alright, first and last, you can get started on that.